Okay, it's been a few minutes since I recorded one of these, so I'm hoping this is where I left off. So this is not in our curriculum to teach, but here it is. So this is, remember we've talked about imaginary numbers, non-real numbers. So we're talking about anything that is a square root of a negative number turns into an imaginary number. So therefore in A, you could take the square root of, you could take the square root of A, and we don't know that B is positive or negative. So because you can take the square root of A, or x squared, sorry, you also have to take the square root of B, and if B happened to be, because remember, it's there, it's a real number, but that just means it could be a negative number, and if it were a negative number, this could have a solution that is imaginary. So this one counts. This next one, I'm trying to remember. I think this one does not, because you'd end up completing the square, which would force it to be positive, because you wouldn't complete the square unless this was a positive integer anyway. It has to be positive and even. So because of that, when you complete the square, you're only going to have a lovely even number to add to a 0, and therefore you're going to have a perfect trinomial. Remember, that's the whole point of completing the square. So this one will not create a non-real solution. However, this next one could, because you could complete the square on this potentially, and if you do that, you're subtracting C, and now you have a potential for this. When you make your perfect square trinomial on the left, you have a potential for a negative. Oftentimes, when we've completed the square, I don't know if you've picked up on this, but your initial C value is negative, so that when you move it to the other side, it moves over positive, and therefore you don't end up with an imaginary issue. That's supposed to say plus C, by the way. So the fact that this is already set up for you as positive C, so that when you move it over as negative C, that's a clue that you could have a non-real solution. I think the only other one is D, because again, to solve this one, you'd have to take the square root of both sides. And when you do, if D was a negative number, you have a non-real solution. I think the answers to this was ACD. I should check real quick. Yes, or ACE. Yes, that's what I meant. So those are the reasons why. Okay, 29, you want to take a standard form equation and put it into slope-intercept form. Therefore, you're going to have 5y equals 3x, because you're going to add 3x to both sides, minus 15, and then you have to divide through by 5. So your slope-intercept form becomes y equals 3/5 x minus 3. That means you're going to have a y-intercept of negative 3. Therefore, that's not 1, that's not 1, and that's not 1. They're trying to trick you with the negative 3 on the x instead of the y. So it's going to have to be b. Moving on. Okay, this is another fun one. I was right, but I was just on the wrong one that you were on. So you have this volume of a cylinder, which volume of a cylinder. So let's say this is the volume of a large cylinder, which equals pi r squared times height, and the volume of a small cylinder, which is inside of it, pi r squared times height. Now the height on both of these cylinders is the same, right? So you're basically substituting 12 in for the height. Now we know for sure the radius of the larger one, which is 10 squared. So now the volume of the large is pi 100 times 12, or pi 1200 for sure. Okay? We got the 100 because we took 10 squared is 100, and multiply it times 12, you get 1200 pi. Now the volume of the small cylinder, we don't know the radius, so we have to leave it as is. And you're going to subtract, so you're basically going to have 1200, this is going to be the volume of both, and they call it V of R, is 1200 pi, that's the large one, minus 12 pi R squared. And that just happens to be this one here. Now to find the next one, the maximum radius is 10, because that's what they put up in the problem, is that the max radius is 10. So you can't have 10, because then that would be the same as the large. And it says that you have to have an integer that is greater than or equal to 3. Okay, so that would be C. You're going to have the largest, it can't be equal to, it has to be less than 10 and greater than or equal to 3, and that's going to be C. All right, for this next one, this is, again, we're fresh off the exponential unit. So your starting value is 150, so this can't be right and this can't be right. And then you're going to take your second number, think about your geometric sequence. You take the second number divided by the first number, and you basically have a rate of change of 3, so therefore C is your answer. Okay, for this one, I actually just threw this equation into my graphing calculator. And remember, you could use Desmos if you don't have one, or there's definitely cheap or almost free apps on your phones you can use. So, excuse me, when you do that and then you hit trace and you put in 8, you'll see you're getting close to the maximum height, but you're not at zeros. So neither of these work. Okay, you want your zeros. And so are you looking for the length or are you looking for the width? Well, here they're telling you in this problem, it's where the x is the width. So your answer is D. And then down here, they mentioned completing the square. I basically went through and took, they're looking for a maximum area, so I did the vertex. I did negative b over 2a, which gave me 9. And then I put it back into the original equation, and I ended up with the number 162, which is exactly what they got in the answer key.